chemicals which are growing again in interest because of their effects on particularly the hormones, called POPs, or persistent organic pollutants. And most of these are xenoestrogens, estrogens. So we've got PCBs, which we hear a lot about. These are electrical and coolant fluids. So these are things that you wouldn't necessarily ingest unless they're in a contaminated form there. But bisphenol A and bisphenol S, you certainly will, because this is in plastics. So these are things which are somewhat soluble. So what you find is bisphenol A, it would be in here, and the softer the plastic, the more there is in it, okay? So it's a solvent which makes it soft. And there's no question about it, it does leak into the water in there, particularly if the water gets warm. If you keep them in the fridge, that's not so bad. So bisphenol A, this has been known as a persistent persistent pollutant, and as a gender bender. Bisphenol S is adhesive. That might be the very thing that's in the sellotape, the sticky tape, which is why people weaken to, when we see with methylation. If they've got a methylation, the adhesive is something, if they inhale that, they weaken to. It might be bisphenol S, I don't know. Non-alphenols, again, these are plastic derivatives in lubricants. DDT, of course, insecticides. Polybrominated diphenyl ethers. These are flame retardants. These all get into the atmosphere, and eventually we get into perfluorooctanoic acid, is flame retardant. Endosulfan, which is an insecticide. Kepone, an insecticide. Vinclozanol, fungicides. Alpha-ethinyl estradiol, which is the birth pill. Genistein isoflavocyanase from soya. Zearalenone, we met that one, didn't we, yesterday? Zearalenone, fungal toxins. Oxybenzone in sunscreens. And tributylin, which is a biocide, insecticide. So these are things which could be on the food, could be in the waters. They're general persistent organic pollutants, which means basically the ones that are in you, they're in you for a long time. And we're all familiar with DDT with that. DDT is particularly difficult to get it out. So of the something like 100,000 tonnes that they made of DDT back in the 50s and the 60s, there's still 100,000 tonnes around. Okay, it hasn't degraded on its own, it's a persistent pollutant. And most of that is in you and I and human beings and everybody, in our fat. Is it a problem? We don't know. What they do know in certain cases, like breast cancers, there's a high level of DDT in the breast cancer tissue. But what they also know is that breast cancer, the fat decreases. So it may be that the DDT just concentrates, so there's nothing to do, it's just stored there, but the concentration goes up. It's the same with aluminium and Alzheimer's disease. They find Alzheimer's veins shrunk, but the level of aluminium is much more concentrated in Alzheimer's because the brain has shrunk. So they don't know whether it's actually a cause or whether it's just an effect of the shrinkage of the brain. So sulfite oxidase is again something which we've spoken about as far as the enzyme to break sulfites down. It's a heme-dependent enzyme. It produces free radicals, which when under strict physiological control act as natural antifungals, which is why they put it into a range of beers and wines and other compounds as well, other preserved foods. But it is an oxidizing agent that produces reactive oxygen species. So here we see the amino acid cysteine being broken down into the sulfate part. So SO3 is sulfite. So SO3 is sulfite, which is quite toxic. So if we add another oxygen, we get SO4, which is sulfate. And to do this, we need an enzyme called sulfite oxidase, which is a molybdenum-dependent enzyme. This then goes on with ATP added twice here to go on to make phosphoadenosyl phosphosulfate, or PAPS, which is generally considered to be the active form of sulfur. And this is what's taken up in myelin and the discs and used for detoxification purposes when we talk about sulfation. So derived from cysteine, the amino acid cysteine, remember that's the sulfur-bearing amino acid, to sulfite to sulfate. So sulfites can inhibit the production of positive gut flora bacteria. So taking foods and drinks with sulfites in may inhibit ultimately your gut flora. They've been shown to deplete glutathione levels, which aid in the metabolism of alcohol. EU labelling laws require winemakers to label contains sulfites on any wine that contains more than 10 milligrams per litre. That's all wines, basically, because all grapes contain sulfites naturally. So without adding sulfate oxidase to it, you do find that you can't actually get a totally sulfate-free wine, even if there's nothing added, which is annoying. So the World Health Authority recommends an intake of no more than 70 micrograms per kilo of body weight, meaning that an average-sized man can safely drink less than a third of a bottle of white wine. 1/3 of Americans are allergic to sulfites. Some it can be fatal. It can be a severe allergic reaction. Remember, that's not a true allergy because it's not an immunoglobulin protein, but it may set up a reaction once the sulfite attaches to DNA and things, leading to, in some cases, asthmas, gastrointestinal and skin irritations. So this is the scientific one. Sulfites inhibit the growth of 4 species of beneficial gut bacteria. So sulfites might be something which to consider when a person has a leaky gut or a permeable gut and gut problems, dysbiosis, that it might be the sulfites that are in the drinks and the foods. Sulfites can naturally, we said they occur naturally in there. There are companies that sell sulfate-free wine, natural pure wines, but the disappointing is that when you look on the labels, certainly in Europe, in the EU, they say in small writing there contains sulfites. What they don't say is it contains added sulfites. So they haven't added it, but they still got to put on contains sulfites by EU law if it contains more than that allowed, which is stipulated. So you never find a wine unless you know the source there. So sulfur dioxide or sulfites protect wine from not only oxidation but also from bacteria. So it stops wine basically going on to make vinegar. Organic wines are not necessarily sulfite-free, as we said, because they have to label it. In the United States, wines bottled after mid-1987 must have a label stating they contain sulfites if they contain more than 10 parts per million. The EU and equivalent regulation came in 2005. EU regulations for organic wines came into force in similarly. So bottles of wine that contain over 10 milligrams contain sulfites on the labels. So it's a bit unfair because people get confused then thinking, oh, this is not a sulfate-free wine. I've ordered a sulfate-free wine, but it says contains sulfites. All you can say is it contains lower amounts. Now there's different ways of reducing the sulfites, even the natural sulfites in there. There are filters that you can use, which tend to be quite expensive because it adds a couple of pounds or so to the bottle of wine if you filter it through there. But we're just working ourselves on a much more economic way of doing this. Should be available at the next module. So a failure in the glutathione conjugation system there would lead to covalent combination, in other words, of the toxin to DNA and RNA with other proteins, and this would lead to ultimately to cell damage. So natural inducers of glutathione S-transferase are spinach, onion, garlic, all those herbs and spices which are so-called blood thinners or cleansers. So glutathione conjugates are further metabolized before they're excreted. Usually they go on to make mercapturates. The glutamic acid and glycine groups are removed and an acetyl group donated by acetyl-CoA. And this then forms N-acetylcysteine, or NAC. So we know that many people would respond very well to NAC, N-acetylcysteine, as a detoxifier. So in a sense, it's a natural compound. It can convert in and stimulate the production of glutathione. It's used traditionally for overdoses of drug medication. So paracetamol overdoses, if you take your overdose of paracetamol, you will go to hospital and they will give you NAC, and this will help to detoxify. And one of the things we use it a lot and prescribe it a lot tremendously is for anesthetics. So a lot of people have problems detoxifying anesthetics, whether they're local anesthetics or whether they're general anesthetics, and NAC will do the trick really, really well. You take it as soon as you possibly can after the anesthetic, after you come round from it, not before, okay? Because the anesthetic simply won't work. And, I've learnt with patients, patients don't really listen totally unless you write it down what they've got to do. So if they take it before the anesthetic, then the chances are they'll wake up. On the other hand, if you take it afterwards, it clears the brain and things. Because some people, with the general anesthetic, it takes them weeks to get over it. They still feel muzzy in the head. So N-acetylcysteine is thus an excellent supplement to activate many different pathways. So it can activate the stimulation of glutathione. The acetyl part, of course, can donate it to an acetylation. So if you're a poor acetylator, it's a sulfation because we got the sulfur here that goes on to make PAPs. And finally, the cysteine itself can attach directly to certain toxins. So there's 4 different ways that it can actually act as a phase 2 detoxifier. Now, the second one here is glucuronidation. Glucuronidation is a sugar or saccharide-like compound. It conjugates by a variety of glucuronyl transfer enzymes. Glucuronidation conjugation is a favoured pathway of many neurotransmitters, hormones, phenol, and benzoic acid. Now, a lot of people show us phenol, as we'll see later on, as an endogenously produced toxin. And I couldn't for a long time. I know phenols are produced in the gut by certain parasites, produce phenols and ammonias and things. But these people didn't necessarily have parasites and things. But the biggest source I found of phenol is phenylalanine, the amino acid. And if people have that problem with the hydroxylation, the phenylalanine hydroxylation, they can't convert phenylalanine into tyrosine. So they get phenylketonuria, which releases the phenols. So when you do a cross-check with the genetics of the phenyl hydroxylase enzyme, you find it's these people who have got poor expressions of the hydroxylase enzyme that get the build-up, they can't metabolize phenylalanine, and it releases the phenols. So if you get somebody with high phenols, check them with phenylalanine, and they're usually weakened to phenylalanine and strengthened to tyrosine, where the problem is in that enzyme. Okay, and benzoic acid. Benzoic acid is a preserver. Benzoates are food preservers, often in many foods and drinks. So natural glucuronics. Favoured one is Jerusalem artichokes. So Jerusalem artichokes contain a lot of inulin, which basically is glucuronic, associated with glucuronic. So Jerusalem artichokes as a powder, which we actually put it with our probiotics because inulin within it acts as a very good prebiotic, but it's a rich source of glucuronic acid. Cashew nuts, soya, licorice, flax, and alfalfa. Sulfation. Sulfation is the third of the big 4 phase 2s. This uses PAPs, which we just described, or phosphoadenosyl phosphosulfate, the active form of sulfur from cysteine. Or sometimes you can use sulfates or commonly elemental sulfur. I tend to like elemental sulfur mixed, but it's a sort of flowers of sulfur is a pretty powerful sort of thing. MSM is another form, MSM, which is derived from the oxidized form of DMSO, or cysteine itself as an amino acid. Alpha-lipoic acid again contains sulfur. Many neurotransmitters and hormones are conjugated via this pathway. So a lot of people use sulfation. So they like sulfur foods. Many spas are sulfur, aren't they? Rich in sulfur. You drink the waters, you have the massage, you have everything to do with sulfur. In this country, I think every spa that developed in 1700 was a sulfur bath. You know, if you go to Leamington and all these places, you can smell it for miles away, can't you? Sulphur's a great detoxifier. So broccoli, asparagus, garlic, onions, mustard, dill, parsnip, horseradish, cabbage, stinging nettles. These are all rich sources of sulphur, elemental sulphur, which are good detoxifiers. So chemicals that are conjugated by sulfation. Acetone is a good biomarker here. DDT, so there we meet that persistent organic pollutant there. Ethylene glycol, that's antifreeze. Fluorine, which is obviously fluorine, fluorides are in water and other compounds. What was it we found that those are in onions, fluorides, onions, parsnip and sweet potatoes, fluorides. Toluene, produced again in the gut by certain parasites and nematodes. And triethylene chloride, which is dry cleaning fluid. These are chemicals which are detoxified normally by sulfation. So if you've got a poor sulfation phase 2 pathway, you would test it with PAPS as the universal sulfur donor, and then you might test and find that people have problems with these chemicals. Acetylation. This is the fourth of the big four. Usually uses acetyl-CoA as the acetyl donor, but you can use other acetyls. We could have a product called acetyl-carnitine, which is a good way of administering carnitine. And acetyl-carnitine can donate the acetyl group as an acetyl donor. So you might want to write those down as alternatives to acetyl-CoA. So as a therapeutic donor of acetyl groups, acetyl-carnitine or acetyl-glucosamine. So acetyl-glucosamine I find is a very good, easy, very soluble saccharide, quite nice tasting. It's good for building up cartilage, etc., which it does as a source of glucosamine. But acetyl-glucosamine can donate its acetyl group to help detoxify. The reaction is catalyzed by acetyltransferase enzymes. So natural ones are endives, peas, cucumbers, watercress and tomato. The drug isocyanide used in the treatment of tuberculosis is usually the biomarker classically that they use to test this pathway. Chemicals are petroleum, newsprint and hypochlorite, although hypochlorite might be detoxified by other things as well. Petroleum, some people find difficulty in going into a garage and topping up with petrol. They feel a bit sort of peculiar and high if they get near petrol pumps and things. Newsprint, I find I'm very sensitive to newsprint. You know, I have obviously an issue a bit with acetylation, and the worst, sometimes it's cheapy newspapers, but the worst things are the magazines on the Sunday newspapers, that if you open them up, they're really bad ink, and you start to read it there, and then your eyes start to sting. And you know the vapours coming off the ink there, heaven knows what the chemicals are, and you're reading this, and then in the end you have to put it down because it just hurts your eyes so much with it. That's acetylation. You remember those days when people used to read newspapers? They don't do it anymore, do they? It's fun to look at them sometimes, though, isn't it? To see a newspaper and you think, oh, that's what people used to do in the old days. Everybody reads them now on the internet. Okay, so methylation. So those are the big four. Now methylation is one of those funny ones which is halfway. So some people, methylation is a primary one of the big four, if you like. We could call it the fifth one of the big four. Or it may be a phase on its own, methylation, before conjugation. So it's catalyzed by various methyltransferase enzymes, and they all technically use SAM, or S-adenosylmethionine, as the methyl donor. So S-adenosylmethionine is a natural substance. A lot of people think that SAM is a drug because it's used a lot for psychiatric illnesses. But a lot of psychiatric illnesses are because of these intermediate substances in the breakdown of noradrenaline, dopamine and serotonin. So these in-between intermediate substances have been known to spark off depression, manic depression, all sorts of things. So these are things like tyramine and things that we talked about before. And they are detoxified by catechol-O-methyltransferase enzymes, which all use SAM, okay, SAM, as the methyl donor. But SAM is a natural form. Sometimes it's called the active form of methionine. It's a natural substance. You can use it as a food supplement. It's very hygroscopic. In other words, it absorbs water very easily. So if you buy it as a powder in a capsule, they tend to have to mix it with a lot of other things. So in the end, you don't know what you're testing. But we find if it's in water to begin with, you might as well, if it's hygroscopic, you might as well put it into water, and it's very stable. But it does have a sulfur smell to it. So there is the compliance that people say, ooh, but if they then dilute it into water, it's not too bad. But it really works really well with people who need SAM because they've got a defect in converting methionine into SAM. For the rest of the people, you need to be able to just recycle homocysteine using those methyl donors like B12 and folic acid or folates, 5-methyl tetrahydrofolate, to recycle it. In which case, most people make, if they get enough B12 and enough folates, they can make their own SAM. But there are some people just where that enzyme, let's have a look, is deficient. So many hormones are initially hydroxylated, then they're methylated and then conjugated. These would be things like the estrogens, testosterone, etc. And they're finally conjugated with glucuronidation or sulfation. Now what we know here is that the best marker for methylation is usually caffeine. The standard caffeine clearance test, you have a dose of caffeine and then they measure the caffeine level in the saliva after half an hour up to 30 hours. And they find that's the half-life difference in many people. So some people can detoxify caffeine within half an hour. 50% of the caffeine will be reduced in the saliva in the mouth. Other people, it's still there after 30 hours. So these are people who are very sensitive to drinking coffee. They can't have a coffee later than sort of breakfast, otherwise it keeps them awake. Sometimes many people can't touch caffeine at all because they just keeps them awake and gives them a relative adrenaline type of high response. So caffeine clearance is the major test. The only problem with caffeine is it's also detoxified by other phase 1 enzymes. So it's not a 100% check for methylation pathway. All you can say is this person has poor caffeine clearance, whereas the glue on sellotape is much more reliable. We found that is 100%. So all you do is you cut a piece of sellotape and you stick it on the patient's nose and you muscle test. And they inhale, they do an olfactory challenge, strong muscle goes weak, they have a methylation defect. It works 100%, and it doesn't mean that people can't use sellotape. It's just sellotape has a glue. Normally most gums or glues stick and that's it. But there's something in sellotape which allows you to take the sellotape off and re-stick it. So it's a solvent of some form which goes through the methylation pathway. I don't know what it is, but it might be that one of those bisphenols. So if we just remind ourselves here of acetyldenyl methionine coming from methionine, making acetyldenyl methionine, and this enzyme called transferase, which transfers the adenylyl part from ATP, leaves it as ADP, is acetyldenyl methionine here, SAM. So some people have a polymorphism there, and what this is on chromosome 10, the Q arm of it, and that gives you the wavelength of it. So people who have that as a chromosome under functioning will have low levels of SAM. For the rest of us, we go on to make homocysteine, and if you want to make more methyl donors, then you get your methylation from methylcobalamin, the active coenzyme of B12, which grabs its methyl group from methyl tetrahydrofolate, which in turn gets it from serine and glycine and so on. So the methyl donor here gives the methylation back to homocysteine, takes us back to methionine, and just recycles again and allows us to continue to make the methyl groups. So most people who have methylation defects respond to methylcobalamin or methyl tetrahydrofolate or SAM. What you don't want to do is give a person really all those factors, because if you give them all, it stops you from producing it. So if you had a person here who strengthens the methylcobalamin and strengthens the methyl tetrahydrofolate, what they would need is the methyl tetrahydrofolate, because then that will donate it to the cobalamin. If you give the cobalamin, it stops this pathway from working. And this 5-methyl-tetrahydromethyltransferase enzyme is quite a common defect on chromosome Q. And this one, the methyltransferase reductase enzyme, again on 5q, you know, same chromosome here, converts and activates 5-methyl-tetrahydrofolate. And this is one of the most common polymorphisms, certainly in America. Something like a third of the population seem to have this. And if you remember that girl yesterday, she had that on her gene reading. So a lot of people actually have that. And Dr. McCullough claims that it's Roundup that's the cause of this, glyphos, which is causing the polymorphism. So people are developing the inability to activate folates sufficiently because of certain pesticides and herbicides. So if you cannot recycle and make enough methyl donors, there's a backup system which may be as important, which is from the vitamin B choline to betaine or betaine, and it goes on to make dimethylglycine here and on to glycine eventually. And at this point here, it gives off a methyl group, and this particular enzyme here is zinc dependent. So zinc comes into the equation again, in this case as a precursor to making more SAM. So we might consider here magnesium, zinc, B12 methylcobalamin, 5-methyl tetrahydrofolate. So not by any means everybody needs SAM. As a supplement, most people need methylcobalamin, 5-methyl tetrahydrofolate, or zinc. So that's another way. This is an acetate we did some years ago now, which just puts in, again, the S-adenosylmethionine pathway. So this cycle here is the methylation pathway. So we make methionine, converts into S-adenosylmethionine, S-adenosyl homocysteine, which then will naturally go on to make cysteine, and then cysteine to cysteine sulfite, which then goes on to the sulfates, which we talked about with PAPS. Or the cysteine sulfite can then be further decarboxylated down to hypertaurine and taurine. So here we see SAM, B12 here, cysteine, glycine, NAC, taurine, PAPS, glutathione. These are all the detoxified molecules within this. So understanding the methylation pathway is really key to many, many defects, not just methylation itself. So everything from down below here, homocysteine, this would be the methylation part, and below here would be called sulfation or transsulfation, because these are all the sulfur donors to detoxifying. Other compounds that can conjugate taurine, glycine, cysteine, threonine, and classic one with glycine is sodium benzoate. So sodium benzoate and benzoic acid are food preservers. So the classic biomarker used to test the glycine pathway is sodium benzoate. So summarize that with X being the xenobiotic, hydroxylated and then conjugated with these different compounds, glutathione, glucuronidation. And this chart gives you then the nutrients that you might consider to use to stimulate those pathways.